Today we're going to take a more formal look at sequences and series, and we're going to look at a series and sequences that are called arithmetic. So again, let's look at the word arithmetic. You may know that word as arithmetic, but we call these arithmetic sequences. And arithmetic sequences are a sequence with what we call a common difference between each term. So sometimes you can see the patterns pretty easily, and sometimes it's a little bit more difficult. So let's take this first sequence. What do we mean? Is there a number that each one of these terms differ by that are common? And in math, what we mean by common means they have the same difference. So let's look at this. So the difference between -4 and 1 is a 5. The difference between 1 and 6 is a 5 and a 5. So sure enough, so this is what we would call an arithmetic sequence. Let's look at this second example. 3, 5, 9, 15. You might be able to see the pattern. We have a pattern. It's 2, then it's 4, then it's 6. So we might be able to continue to get the next couple terms, but because these differences are not the same difference, we would say that this is not arithmetic. So one of the things you'll be asked to do is just to tell whether a sequence is arithmetic or not, and what you're going to be looking for is that the terms differ by the same amount. So the next thing we're going to look at is a formula, and this formula is going to be used to be able to find, maybe a term like the 10th term, or maybe even find the 100th term, and we would not want to go and just keep on going and going and going and going to try to find the 100th term. So we have what's called a formula for an arithmetic sequence. And I want to tell you what each one of these variables are. A sub n is the value of the nth term. The notation for a sub 1, think of this as the first term. D is that common difference that we just talked about. And finally, n is the term number that we're looking for. So let's take this sequence, 4, 9, 14. Does it have a common difference? 5, 5, 5, 5. Yes, I could probably get to the 10th term by just keep on adding 5 to each term. But if we wanted to find the 100th term, I don't think we want to go through this whole process. So let me show you how we'll use our formula. So just rewrite the formula down, and I'll show you how we plug it in to find a particular value. Let's do the 10th term first. So put a sub 10 equals, the first term in this sequence is a 4, plus this d stands for the common difference, which in this case is a 5. And if we want to find the 10th term, we actually put a 10 in for the term number, which would be 10 minus 1 here. So let's do this math. So we get, what is the value of the 10th term? 4 plus 5 times 9 is 45, and 45 plus 4 would be a 49. So our 10th term, if we continued here, would be a 49. Okay, now that's not that exciting, but again, what can really make the difference here is if we go to the 100th term. So let's see if I can figure that out. If I just stick 100 in here, that would mean that I change 100 in here. So the 100th term is going to be 4 plus 5 times 100 minus 1 is 99. So we'd get, what is that, 45, 49, 495 plus the 4, we'd get a 499th would be our 100th term. And again, I hope you can see where the formula comes in handy here. And this formula will work only if we have an arithmetic sequence and if we have a common difference. So let's take a look at a sequence where it's going down. How would that work? Again, let me suggest that you copy the formula down and then simply substitute in what we see and how we'll get that. In this case, let's say we want the 10th term. We take the first term, which in this case is a 60, plus the common difference. If I'm going down, it would be a -8. And again, if I want to find the 10th term, this would be a 10 minus 1. So to find the 10th term, I'm going to take 60 plus -8 times 9 will be a -72. So 60 plus a -72 will be a -12. So what I'd like you to do now is stop and do the front of today's assignment and then come back and I'll pick you up with formulas to find the sum of an arithmetic sequence. Welcome back, and what we're going to do is we are going to find the sum. And you remember from Friday that when we talked about the sum, this sigma notation meant sum. So we are going to find out if I put in a 1, I'll get 8. If I put in a 2, I'll get a 13. If I put in a 3, I'll get a 3 is 15, 16, 17, 18. And about this time we talked about seeing the pattern, and we are going to, again, we could just go on about seeing the pattern and add all these up, but this time we have to add up 20 numbers. And I'm not sure we want to keep adding all 20 of those numbers to get the sum. So we have what's called an arithmetic series formula, and it simply goes like this. S sub n is the sum of n numbers. N is the number of numbers we're adding up. A sub 1 is the first number. And A sub n is what we call the last number. Or the first term and the last, I should probably call that term. So let's see how we're going to use this formula. So if I want to find the sum of all 20 of these terms, and again, how do I know I have 20 terms? I start with 1 and go up to 20, so that'll give me 20 terms. N is 20 terms. The first term is putting in a I equal to 1 here will give us our first term. So we saw that the first term was equal to 8. Now, instead of going all through this to find the last term, we know what the last term is. All we need to do is stick a 20 in for I. So 5 times 20 is 100 plus 3. Our last term will be 103. So the sum of these 20 terms are going to be 111 times 20. You can do that on your calculator if you want. We should get 2,220. And I think that will be a lot faster way than putting all 20 terms down and hitting the plus sign in each one of those. So hit pause, see if you can do example 4 with the formula, and then I'll check to see if you're right. So how'd you do? The first thing you have to check is to make sure that we have an arithmetic sequence. So let's stick in a 1 here. So if I stick in a 1, I get 4 plus a -2, I'll get a 2. Plus if I stick in a 2, I'll get an 8. Minus 2, I'll get a 6. So it's looking good so far. If I stick in a 3, I'll get a 12, and 12 minus 2 is 10. And about now, we can see that our common difference is equal to a 4. So this tells us an arithmetic sum. Can we tell how many terms we are getting? We should see that we have 28 terms. So the sum of these 28 terms is going to be 28 times the first term, which the first term is sticking I equal 1 in here, and that was a 2, and our last term. And our last term is, if I stick in a 28, so 4 times 28 is, looks like about 112, plus that negative 2, that'll give me 110. So again, you could keep on going and get up to 28 terms, but I don't think we want to do that. So this notation means the sum of these 28 terms will equal what? 28 times 112. Check my math here. I think we should get I think our final answer is 3,136. So now you should be able to do the back where it's a sigma. And again, you've got 2 formulas. Make sure you box those formulas up and ask any questions if you don't understand.